Today's learning target is I can simplify rational expressions. So it is I can simplify rational expressions. Remember, the word rational means anything that can be written as a fraction. For your warm-up, I want you to go ahead and on your own factor each one of these. Okay, number 1, you should have gotten x plus 2 times x plus 3. Number 2, you first factored out the GCF of 4. You got x squared minus 16, but then you saw this was a difference of 2 squares. So you got 4 times x plus 2 times x minus 2. Number 3, you should have factored and got 2x plus 1 times 2x plus 1. Number 3, hopefully you recognize, was a perfect square trinomial. The square root of 9x squared was 3x. The square root of 100 is 10. 3x times 10 times 2 is 60x. So that is my middle term. So you could have said, oh, well, that's just 3x plus 10 quantity squared. So first, let's look at the definition of a rational expression. It is an algebraic expression whose numerator and denominator are polynomials. The denominator cannot equal 0. Just like any fraction, a denominator, or the denominator in more simple terms, you know, is the bottom of the fraction. So we're going to follow these 3 little steps. Find any excluded values. Any excluded values of the rational expression means it's going to make the denominator equal to 0, which is not allowed, so it's not allowed to happen. So the way we're going to find out what's not allowed or what's going against the rules is set the denominator equal to 0, because that's going to say these are all false. So let's take a look at number 1. We're going to set t plus 5 equal to 0, because that's not allowed to happen. Factor is possible, there's no GCF, and now let's solve. So minus 5, and you get t equals negative 5. So that means this is not allowed to happen. So since t is not allowed to equal negative 5, we would put a little slash through that. Because if you did, let's just show you what would happen if t did equal 5. You'd have 12 over negative 5 plus 5, which is 12 over 0. You can't have that. So t is not allowed to equal 5. Let's take a look at number 2. What's going to make this equal 0? Remember, this whole thing is not allowed to equal 0. So b squared plus 5b is not allowed to equal 0. So let's see, can we factor? Oh, I see a b. We have a GCF of b in here. So remember, you factor out your b, and then you get your leftovers. Divide by b, divide by b. So b squared divided by b is just b, plus 5b divided by b is 5. All of that is not allowed to equal 0. Now, if you look at it, b times something's not allowed to equal 0. Since neither one of those are allowed to equal 0, each factor is not allowed to equal 0. So put a little star next to here, because wouldn't it happen if this right here was 0? Wouldn't you have 0 times something, and that would equal 0? Well, that can't happen. So the b all by itself is not allowed to equal 0. So you can simply take your first factor right here. This is factor 1. This is factor 2. So factor 1, b, is not allowed to equal 0. Factor 2, b plus 5, is not allowed to equal 0. So when you subtract 5, you get b is not allowed to equal negative 5. Well, Mrs. Gibson, I don't know if I believe you. How do we get 2 different answers? We got 2 different answers because it was squared. If you would check, each factor is not allowed to equal 0. So for instance, if you had 3 times 0 and the right factor was equal 0, wouldn't it equal 0? Or if you had 0 times 3 equals 0, no matter where it was, whether it was in the first factor or the second, anything times 0 is going to equal 0. So neither one of the first or the second factor could equal 0. Why don't you make yourself a little note that says neither factor could equal 0. Let's take a look at number 3. We know that this whole denominator is not allowed to equal 0 because it's a fraction. So k squared plus 7k plus 12 is not allowed to equal 0. There's that squared again. When you see something squared, it usually means you get 2 answers. So let's factor this. What can multiply to be 12 but add to be 0? So we have k and k. How about k plus 4, k plus 3? So we have factor 1 and factor 2. Remember, neither factor could equal 0. So k plus 4 could not equal 0, and k plus 3 could not equal 0. Now let's solve. Minus 4, k is not allowed to equal negative 4, minus 3, and k is not allowed to equal negative 3. If you plug either one of those in, you'd get a denominator that equals 0. And that is just not okay. It's not allowed to happen. So now we're going to simplify. We're going to do the same thing. First, we're going to factor wherever possible. Then cancel any factors that appear in the numerator and denominator. If a number is before a variable, factor out a negative 1. Simplify each rational expression. Identify any excluded terms. Let's do the identified excluded terms first. We just did that. So we know for the excluded terms, this denominator is not allowed to equal 0. So we know 15m is not allowed to equal 0. Divide by 15, divide by 15. M is not allowed to equal 0. So that's my excluded term. Now, let's solve. Well, if I have 5m squared divided by 15m, and we're going to simplify, well, let's look at our coefficients. 15 and 5 can both be divided by 5, so you get 1 over 3. And then m squared divided by m is just m. So this simplifies to m over 3, where m is not allowed to equal 0. And we got that from our excluded term. Let's take a look at number 5. First, let's see if there's any excluded terms. We'll do it in blue. So we know this is not allowed to equal 0. P squared plus 2 is not allowed to equal 0. Well, p squared minus 2 is not allowed to equal negative 2. Well, is anything squared ever going to equal a negative 2? No. So nothing squared can equal a negative 2. This is never going to happen. So you have no excluded values because this can't happen. So that can't happen. That will never happen. So let's go ahead and let's look here. Can we factor anything out of my numerator? Well, I see a GCF of 6p. So when you factor 6p out of the numerator, you have leftover when you divide by 6p, divide by 6p. 6 divided by 6 is 1. P cubed divided by p is p squared. Plus 12 divided by 6 is 2, and your p's cancel. All over p squared plus 2. What do you notice the same in the top and the bottom? I see p squared plus 2. P squared plus 2. And they're both inside parentheses. So what do you think can happen to those quantities that were the same in the top and the bottom? It's just like having 2 over 2. Anything over top of each other cancels, and you're just left with 6p. And that's all you have. Number 6. First, we know we need to say that n minus 2 is not allowed to equal 0. Add 2, n is not allowed to equal 2. So that's my excluded value. Can this simplify any further? I can't factor anything out. I don't see any common binomials. So you just can't factor. Number 7. First, let's check for excluded values. Ooh. See how my n squared comes second? I want it to come first. So anytime that your n squared comes second, let's go ahead and put it out front. So we would have negative n squared plus 64. But remember, factor out the negative. When you do that, you get negative 1 times n squared minus 64. But now we have a difference of 2 squares. So this right here is a dots. A difference of 2 perfect squares. So you get negative 1. The square root of n squared is n. The square root of 64 is 8. So you get n plus 8 and n minus 8. So now we can continue working up top. So we can factor the 2 out. This guy has a GCF of 2. So you have 2 times the quantity n minus 8 over, we simplified the denominator right here to negative 1 times the quantity n plus 8 times the quantity n minus 8. Do you see a common binomial? I do, right here and right here, n minus 8. So you get 2 over negative 1 times the quantity n plus 8. But let's just make the negative in the numerator negative 2 over n plus 8. We didn't find our excluded values yet, so let's go ahead and do that. So we know that this whole denominator that we already factored, the negative 1 times n plus 8 times n minus 8 is not allowed to equal 0. And again, each factor cannot equal 0. So negative 1 cannot equal 0. Well, that's always true. N plus 8 is not allowed to equal 0. Subtract 8, subtract 8. So n is not allowed to equal negative 8. So I'm going to put that over here. And n minus 8 is not allowed to equal 0. Add 8, n is not allowed to equal 8 either. So here's your whole answer. Make sure that you factor everything inside of here. Do your numerator, do your denominator, and then go ahead and put them together.